Section 2.5 is all about matrix multiplication. You can't just multiply any two matrices together. A certain condition has to be satisfied in order for the product to even exist. So that's what this first little paragraph is about. Given two matrices A and B, in order for the product AB to exist, the number of columns of A must be equal to the number of rows of B. And as we go through the examples, I'll show you an easy way to figure that out. And then the size of the resulting matrix AB is going to be, you take the rows from A and then the columns from B. Alright, the way we go through these examples is really easy to figure it out. Let's start with this example. It says, does the product AB exist? If so, what is the size of that product matrix? Alright, so part A is kind of easy. Let me put it over here. A is a 2 by 2 and B is a 2 by 2. I like to write them right beside each other. So remember that this is a rows and then the columns. Those are rows and columns. So the number of columns of A, which is right here, has to match the number of rows of B. So it's going to be those two numbers right next to each other if you write it that way. Okay, as long as they match, then the inverse exists. Does the product exist? Yes. I said inverse. The product exists? Yes. And then to get the size of matrix AB, you take the rows from A and the columns from B. Those are those other two numbers. Right? So it's going to be a 2 by 2. That was easy because both of those are 2 by 2s. Alright, yes, it's going to be a 2 by 2. Let's check it out with part B here with the different A and B. Okay, let's write it over here. A is a 3 by 1 and B is a 1 by 3. Okay, if you write them side by side like that, you check those two middle numbers. If they match, yes, the product exists, and the size of that product is going to be those other two numbers, 3 by 3. Alright, a little bit later we'll find out how to actually multiply the two together, but for now we're just seeing if you actually can multiply them. Part C. Alright, A is a 2 by 3, B is a 2 by 3. Alright, look at these two numbers in the middle. They do not match, so you can't even multiply those together. Can't multiply them. Don't even worry about those other two numbers. If the two in the middle don't match, then you just say no. You can't multiply them. Alright, here's part D. Let's just write these sizes over here. A is a 4 by 2. And B is a 2 by 2. Alright, we circle these two inside numbers. So yes, the product matrix exists, and it's going to be a 4 by 2. Those are those other two outside numbers. Just like that. Alright, here let's try E. Both of these are, well, 1 by 3s. Looking at those two inside numbers, that's a big no. Alright, you can't multiply those together. Though some students, just want to try to multiply those corresponding entries, you cannot do that. You can't do that. When we multiply them, we have to talk about dot products, and we'll talk about that in a little bit, actually. Yeah, like right now. Okay. So you can't just multiply any two matrices together. The number of columns in A has to match the number of rows in B. But if you write it like we were up here, squeeze those two numbers together. If they match, then yes, the product exists, and the size will be the other two numbers. Alright, here's the procedure down here. It says we must use dot products. So let's talk about what dot products are first of all. A dot product, for example, is like row 1 dotted with column 1. And here's an example with two 2 by 2 matrices. We're just going to look at a dot product for now. Alright, let's look at row 1 dotted with column 1. The R means row, The C means column. And so it's row 1 dotted with column 1. Alright, looks like this. I'm going to write it out. Let me see how much space I have. I have enough space. Alright, here's a dot product. It is like multiplication, so for the dot product you actually do want to use a dot there for that notation. It does mean multiply. Okay, so you're going to take, remember this first one comes from A, the second one comes from B, so I'm going to take the row 1 from matrix A, and I'm going to take column 1 from matrix B. Row 1 and column 1 like that. Alright, I'm going to rewrite it here. Here's row 1. Right, I just sort of grab that row and I'm going to dot it with the column, that first column. Alright, this is really writing out what a dot product is. A little bit later when we start multiplying matrices, we're not going to write it out like this each time. Okay, a dot product, row 1 dotted with column 1. What you do is you take the negative 2 times the 5 and you add it to the 3 times the 7. Just like that. That's a dot product. Alright, so that's going to be, what, negative 10 plus 21 gives you 11. A dot product is going to return a number. So row 1 dotted with column 1, we just took the row 1 from matrix A, column 1 from matrix B, and what you do, you take the negative 2 times the 5, and then you add that to the 3 times the 7, like that. Alright, you kind of go across and down. And it should always return a number. It might be positive, might be negative, might be 0, that's okay. It's just a dot product. So, let's scroll down, and we're going to do this quite a bit, so I'm not going to write it out each time. I'll write it out this first time, right, because we're just learning these dot products. This says, to multiply matrix A, which is a 2 by 2, by another 2 by 2, for example. Again, you could expand this to 3 by 3s, but, or any size, as long as you can multiply them together. Alright, let's look at it for 2 by 2, 2 by 2s. The product matrix is going to look like this. It is a matrix of dot products. And in this 1, 1 position, it's going to be the dot product of row 1 dotted with column 1. In the 1, 2 position of your product matrix, it's going to be the dot product, row 1 dotted with column 2. Whatever position you're in, that's the dot product that you're going to do. Here, this is row 2, column 1. This is the 2, 1 position. So you take row 2 from matrix A, dotted with column 1 of matrix B, and then this is the 2, 2 position. So you can see that dot product there. Let's try it. Alright, this is the same A and B from before. Make sure I type that the right way. Yeah, negative 2, 3, 1, 6, and negative 4, 7, 2. Okay. Alright, we're going to multiply these two together. Let's find that product AB from the previous example. Alright, so here's my product matrix. I'm going to write it down here. And I'm going to put the dot products in here. Alright, this is the 1, 1 position. And some students like to identify the rows of A. This is row 1, that's row 2, and then the columns of B. That's column 1, column 2. It helps them with their dot products. Okay, well I can see the dot products right up here. Alright, let's find this dot product. Row 1 dotted with column 1. Alright, row 1 with column 1. I'm going to write this out. That was negative 2 times 5 plus the 3 times 7. Right, we went across the row 1 for A and dotted it with column 1 of B. Alright, let's move over here to the 1, 2 position. Let's move to this one. Row 1 dotted with column 2. Alright, the same row 1, so let's start with negative 2, this time dotted with column 2. Negative 2 times negative 4 this time. and we're going to add that to 3 times 2. We just did, we went across row 1 and down column 2. Okay, multiplying those, the first one here times the first one there, second one there times the second one down there. Alright, let's go down here. This is going to be row 2, column 1. I'm in the 2, 1 position right here. So this is row 2. I'm going across this way and down. So 1 times 5 plus 6 times 7. Right? And the very last one, this is the 2, 2 position, so I need row 2 dotted with column 2, 1 times -4 plus 6 times 2. Alright, let's see what all of this is. This is actually a -10 plus 21. I already did that one last time. I'll actually write out what that equals down here. This is, what, 8 plus 6. Down here, I've got 5 plus 42, and then over here, -4 plus 12. Obviously, you're not going to show these steps. You know, I want you to show one of these steps maybe like this, because your calculators multiply matrices as well. So instead of just knowing how to key it in your calculator, you don't have to show me this step over here, but show me, you know, these dot products where you're adding these numbers together. And you're not having your calculator do it. Alright, that's 11. This is 14. That's 47. And that's an 8. Doesn't look like an 8, but that's an 8. I'll write that better. Alright, that's the product matrix AB. This is the answer. Alright, that was AB. And it's a 2 by 2 because we multiplied 2 2 by 2's together. So we did dot products in order to do that multiplication, matrix multiplication. Yeah, let's try it again with these different size matrices, these two. Alright, let's just look at the sizes. A is a 2 by 3, just so we can see what the size of the resulting matrix is going to be. B is a 3 by 1. Alright, so AB is going to be a 2 by 1. Alright, so I'm going to have 2 rows and just the 1 column for my very end, for my AB matrix. Alright, let's write it out down here. What I'm going to have, remember I'm going to have 2 rows with just 1 column. So I'm going to have a dot product here and a dot product here. You can list, if it helps you, row 1 over here, row 2, it only has, B only has a column 1. So what we're going to do for this first position, this is row 1 dotted with column 1. Alright, so you go straight across row 1 of column A and straight down column 1 of B. So you take 3 times 6, which is 18, plus the -5 times 1, plus 10 times the -2. That's that first dot product. That's in the 1, 1 position. Now, down here, remember this is one big column and 2 rows. Alright, so now we need row 2 dotted with column 1, -2, oops, I'm not going to write that, -2 times 6, let's just write -12 there. Alright, plus 4 times 1, oh gosh, I didn't mean to write those, I just meant to write what those were. I'm going to go back and redo that. Plus 0 times the -2 is going to be 0. Alright. Yeah, that was right, but I'm not going to show that step anymore. Okay, row 1, dotted with column 1. 3 times 6 is 18. Okay, plus the 5 times -1 is going to be a -5 here. That's how I want to do it. Plus the 10 times